Module 9 is about the time value of money, and where chapters 9 or modules 9 through 13 are going to go over time value of money concepts. Chapter 9 in your textbook and Module 9 is just a review of just the really basics, and then we'll build on those concepts for the rest of the semester. Chapter 9 in your textbook uses money tables to solve problems. You're going to use your financial calculator in Excel. The answers in the book for the examples are fairly close to what you'll find, but those tables aren't quite as accurate as your calculator is, so there may be slight differences in rounding issues. I assume that you know how to use a financial calculator because you should have used it in prerequisites for this course. If you need help, you should contact the instructor. We're going to look at what's included in an interest rate, compound interest, and then finding the present value, future value, payments, and perpetuities. And we're also going to look at effects of time and interest rates. So what was the most expensive drink you purchased? Why did you pay that much for it? Think about that for a second. If you're thinking of a pop at a movie theater may cost around $3 to $4. A pop at a gas station, about $1.20. If you wait and get it at a grocery store, probably about 60 cents. And if you wait to get it on sale at a grocery store, probably about 30 cents. So why do you pay more? Because you wanted it now. If you're going to wait, you need to be compensated because you'd rather have it now. So if you have to wait for it, then you want to be compensated. This is just like interest. You're willing to pay more to have it now. So in order for the bank to give you money now, you have to pay for it because the bank can't use that money now. They'd rather have it now too. And so if you want it now, you have to pay extra. Or in order to let somebody else use your money, they need to pay you. So one component of an interest rate is time. Someone is compensated for delaying the use of their money. With a loan, that is the bank. With savings, it is yourself. Another part deals with a question. People usually sometimes they'll put a hand on their hip and say, when I was your age. And it can go on with different types of questions. But one of them is, in 1950, a candy bar cost 5 cents, or a nickel. Was candy more or less expensive? Just looking at the price would say it was less expensive. However, we don't know what the effects of inflation were. Inflation means that everything gets more expensive over time. So some things get more expensive faster and others slower. To find out the value of something in today's dollars, we use an inflation calculator, and it's available at www.bls.gov for Bureau of Labor Statistics, and then you can search for inflation calculator, or I've got the complete address there for you. So it looks like this, and you have a spot here to put in an amount, and this drop-down menu will let you put in anything from the really early 1900s up to 2011, and then the year that you want to compare it to, which a lot of times if it's for today, it's 2011, and then you'd hit calculate. So here is your nickel in 1950, 2011, and then when we hit calculate, it tells us that that's worth 47 cents in 2011. 47 cents is probably a little cheap for a candy bar today. They're probably about 75 cents or so, and so candy bars were actually cheaper when they were a nickel in 1950. So if you delay the use of your money, it's going to buy less in the future, so you need to be compensated for the effects of inflation. So once you get your money back, it'll buy as much as it did before you gave it to somebody else. So there's a third component to risk, and it's that there is a bigger chance you will not get your money back. And if you have a chance that you won't get your money back, you want a bigger chance that you will get way more money back. So you need to be compensated for the risks with possibilities of bigger returns. This happens through a higher interest rate. If you're a bigger risk, the bank may charge you a higher interest rate if they lend money to you at all. So your three components are time, inflation, and risk. Time and inflation are the same for everybody, but risk is the factor that changes with individuals. Compound interest means that over time you earn interest on interest. If you have an annual compounding, after 1 year, the interest earned in the first year is added to the balance the following year, and then interest is earned on the original amount plus interest in the first year's interest. If it's monthly compounding, interest earned after the first month is added onto the balance, and then in the second month you'd have interest being earned on the interest, and all the subsequent months. With which compounding period would result in the largest amount earned, a daily, a monthly, or a yearly? Think about that for a second. And the answer is daily, because you would start earning interest on interest the fastest. So here's an example. You save $1,000 at 10% interest, compounded annually. This would result in 10% times the 1,000 equals $100 of interest earned during the first year. And so at the end of the first year, you'd have $1,100, your original 1,000 plus $100 in interest. In year 2, you're going to earn 10% on $1,100, which is $110, and the balance would be $1,210. Your $1,100 plus the $110 that you earn in interest. For monthly compounding, you would need an interest rate per period or per month. So you take your interest rate of 10% and divide it by 12. And then you'd multiply that by 1,000, and that equals $8.33. So that's the interest that you'd earn during the first month. You add that balance at the end of the first month, you'd have a balance of $1,008.33. So the interest of $8.33 you would earn interest on that during the second month and later months. So we'll learn how to calculate this in other problems next. So calculating your answers, there are 5 different amounts that you can solve, and you can solve for any of them if you have the other 4. And they include N, which is the number of periods, I is the interest rate per period, present value is the value today or at the beginning, PMT is the payment or the set amount per period, and FV is the future value, the value in the future at the end. So the number of periods here, N, would be the number of years times the compounding periods per year. So if it's monthly payments for 3 years, it'll be 3 times 12 is 36. The interest rate per period, so you take your annual interest rate and say it was 10%, and you divide it by 12 to get the rate per month. For each problem, I suggest you write down those 5 things, N, I, PV, PMT, FV, and then put what they're equal to, and fill in amounts for 4 of them, and some may be 0. Then solve for the 5th one either using a financial calculator or computer using Excel. We'll go through some examples, but more can be found in Chapter 9 of the book on pages 254 and 262. So an example of a future value. You have $1,000 now that you want to invest for 10 years. You can earn interest at 6% per year compounded annually. What will be the value after 10 years? So we have our 5 things down there, and now we've got to fill those in. N equals 10 for the 10 years compounded annually. I equals 6%, our rate. The present value is $1,000, the value today. Our payment is 0 because we're not getting any periodic payment, and we're solving for the future value. And once we put that into our calculators, you should get $1790.85. One thing to notice is that in your calculators, they're assuming that money goes in and money comes out. And so if you have $1,000 now that you want to invest, technically we could put this in as a minus because it's money that you're giving to somebody else, and then your future value would show up as a positive amount. If we're just doing 2 of these 3, PV, PMT, or FV, it doesn't matter if we put the negatives in because we can just observe the answer. It only matters that you're really careful about that when you're using all 3 or solving for your I or your N. If you're solving for your I or your N and you don't put one of the 3 has to be negative, or it's not going to solve for the other anything. So, like I said, you just have to be careful about that when you're using all 3 of them. This is because money goes out and then money has to come in. So another example is to find the payment. When you would like to purchase a pickup, you need to borrow $30,000 now. You'll pay it off with monthly payments over 4 years, and the interest rate is 6% annually. So N needs to be the number of payments. I is the rate per month, so it's the annual rate divided by 12. The present value is the amount that you borrow, and then you're solving for your payment and you have your future value. So this turns out that N's 48 payments. I is 0.5% a period. Your present value is $30,000, and then we're solving for our payment. And when we do that, our payment's going to be $704.55. Another example is to find how much you would need to save to reach a savings goal. You're 25 years old and would like to have $1 million when you retire in 40 years. If you can make 9% on your savings, how much will you have to save each month? So you have to figure out those 5 things. And when you do, you've got 40 years, 12 months each year, so you've got 480 periods. 9% divided by 12 is 0.75% a month. Present value is 0, your payment's uncertain, and your future value is $1 million. So we find our payment is going to be $213.61. Now, let's assume that you have less time to save. So instead of 40 years, you've got to save for 30 years. How much will you need, and how much does it change? So now all we've got to do is change that N to 360. And we solve for our payments, 546. And so previously, if you had 40 years to save, $213, 30 years to save, 546, so it more than doubled what we would need to save. And this is because of the effects of time. You had less time for that interest to compound, or interest to earn money on interest. And so you can see that it took a lot more. There's graphs in the book on pages 267 and 268 that illustrate those effects. And this concludes Module 9, which was just our basic review of the basic time value of money questions. Chapter 10 will go on and look at net present value and IRR.